Hey everyone. So it's been a few months since I've done a video, and I've done quite a bit of work, so just want to go ahead and make another post and show off some of the new stuff. The first thing to talk about is I've completely redone the entity component system. I've made the API a lot nicer to use. Instead of everything being completely data-oriented in design, I've moved it to a more modular approach, very much like Unity's. And one thing you'll notice here is coming along with that is transformation hierarchies that I've implemented. So I can parent and child entities to other entities. So you see an example of that here. I have a cat entity, and it has directly below it, this green box is the child of the cat, and then the green box has the red and the blue boxes. All of them are rotating with respect to the parent's transformation, and so forth and so forth. And I can show you that actually working if I go up here and I edit the position of the parent, the top parent. You see that all of them move with respect to that. If I edit the scale of the parent, then you can see they all scale appropriately as well. And the rotations are the same as well. You can see those updating in real time. Okay. Next thing to show off is the rendering is quite a bit different now. I've completely taken my rendering system, redid everything. It's a full-fledged subsystem now at my Enjon, and I've implemented PBR. So I use complete PBR for my rendering. So it's a metallic and roughness workflow. If you're not familiar with PBR, then it's basically just it's a realistic way to describe visually how materials actually interact with light in the world. The problem with the previous implementation of lighting that I was doing is that it's not energy conservant, whereas PBR makes sure that the amount of energy that goes into the material is the same amount of energy that leaves the material. So with that, you get fairly realistic materials, such as this metal here. Let's see, realistic Fresnel, and reflections here. These reflections are because I'm using IVL for ambient and diffuse lighting. Which actually, if I turn my sun off, you can see all the lighting in the scene right now is actually coming from the ambient light, which the way that I do that is I take a HDR image, and then at the beginning of the startup I do some convolution on that, pre-filtering into two different cube maps. So you have diffuse irradiance, and then you have specularity radiance that you get, and then use those, and in calculations in my ambient pass you get the ambience for the scene. So you can see all the different reflections in here are coming directly from this cube map here, as well as all the ambient diffuse lighting. And we can look at some different materials that I have laid out here. This is a plastic kind of material. So again, the PBR equation deals with, if you've ever used Unreal or yeah, Unreal is probably the best example because of their material system is basically set up with this, and it's right there in your face whenever you're making materials. But if you look at theirs, they have metallicness, they have roughness, albedo, normal, things like that. Those are really the main things that will describe your material. And so if we look at this, this has a barely any roughness at all. You can see the normal. Turn over to the normal buffer. You can see all the indentations, the normal map here, the albedo color, right? and actually I am drawing out the materials. So I believe my roughness and my metallicness are both in, let's see, the roughness is in the A channel of this render target, I think, or not the A channel, the R channel, the G channel, I think is my metallic. That might be round, actually. No, I think my metallic is actually red. Anyway, doesn't matter. But you can see all the different material properties of all the different objects in the scene. Actually, if you go over and look at this matrix, this is a really good example. And typically something that people do whenever they're trying to show off PBR materials is they'll set up a small 4x4 or 10x10 matrix, however big they want, of all the different materials that are actually being represented. So if we look over here, starting, we call this 0, 0. This is not rough and not metallic at all, so it'd be almost like a shiny plastic. Look at there. And then as we start moving down this way, we get more metallic. So this is not rough and fully metallic. So very reflective metal. And as we start moving more to the right of the matrix, we get more and more rough. So this is fully metallic and fully rough. Not so rough, not so rough. And then this is not metallic at all and fully rough. So just with this alone, I think it's pretty easy to see that you get a pretty wide variety of different materials that you can come up with. And in pretty interesting combinations, you can very easily describe any material that you'd like to within reason. I say within reason because I don't have any transparency yet. I don't have a forward pass set up. And there are certain other things with post-processing effects that you can do in Unreal with different materials that I don't have set up yet. But I'll get there eventually. Let's see, I've also done a lot of tone mapping. Real quick, I will say that right now I'm using IMGUI for all of the UI. IMGUI is really good to quickly knock out some quick UI, some quick design. This took no time at all to get up and going. So if you haven't ever looked at that, I recommend looking at IMGUI. Specifically Dear IMGUI. It's the particular library that I'm using on GitHub. You can find that pretty easily. But the bad thing about Immediate Mode GUI is that when you want to go to something more scalable, or you're wanting to retain more state, you're having to abstract a lot out of IMGUI and use it for things that it's not meant to be used for, namely retain state. So it begins to become a bit of a hassle. So I might switch from this and go to something. I definitely want to go to something more retain state, but I don't know if I'm going to make my own implementation or if I'd go to something like Qt. I don't know, but I'm probably going to get away from IMGUI, even as nice as this is to use to quickly block some things out. It's just annoying to have to write wrappers around it to have retained state, and I'm afraid of the performance that it'll get for doing things like that. But I don't know, I might be wrong. Anyway, back to this. Just some small tone mapping stuff that I've implemented. The bloom I've spent the most time on. We can actually go look at this. For bloom, I wanted something nice. The issue with a lot of bloom implementations is that you get a lot of banding whenever you do the Gaussian blur. And the reason for that is that typically you do one pass on the bright target. So the way bloom works, for those who aren't familiar, is you have this is the lighting buffer, right, for my G buffer, or not my G buffer, but the lighting pass. So this is the render target for that. You take this, you do a brightness pass on it, which I have that here. Basically, this is look at all of the pixels on screen, right? Look at all those, see if they pass some kind of threshold for the luminance value, and if they do, then they get put into this brightness buffer. Right now I'm messing with this threshold here. You can see that as the threshold gets lower and lower, more pixels are going to be let in. And it's probably hard to see on YouTube, but now more of the scene is getting let in. There we go. You can probably see that a lot better. So now everything, almost everything, gets put into this buffer, and so it will take this brightness buffer and it downsamples this a bunch of different times and does different blur passes on it to get my different layers of bloom. I do 3 layers of bloom, and then I do separable blurs on all of those. So I start out with a small blur, go to this, and I blur this a number of iterations. Right now I have it set to 3, and it's separable, so that means it's actually 6 passes. So it'll do 3 vertical and 3 horizontal. If I up this, you can start to see it get a little more blurry. Okay, I also have radius, so this is the amount of steps that it'll take with each of the blur in the kernel. So this is the offset of texture reads that it does whenever it does the blur. You can set this pretty high, and then you can blur some more, and you'll get rid of some of the stepping, but the kind of defeats the point to do this, because the reason that I have it set up into different stages of blur is that I get a blur that would like that a lot cheaper because I do it with smaller resolutions, and then I just blur those and then add them together at the end. So the medium blur, go to that frame buffer and show you that. So again, this starts to kind of look like what was doing a second ago with that smaller blur, but it's cheaper because each time that I do these render targets for these blurs, I halve the resolution of what it was before. So the small blur is at half of the screen resolution, this medium blur is half of that, and then the large blur is half of that. I'm using 3 blurs for this, and then compositing those. Unreal does up to 6, and they get a really nice final blur. I've been pretty happy with just doing the 3, so I might stick with this. But I don't know, I might mess around with the others. But anyway, so you take all those downsample blurs, and then when you're compositing, you upsample every single one of those and blur it again, and then you add it to the last one, and then in the compositing stage, you just additively blend that into the final image. And then you get this, and I think you get a really nice effect. And then finally we have some, the scale just takes the overall scale of the blur and makes it larger. It's pretty self-explanatory. Okay, and then underneath that, some other simple tone mapping stuff that you would typically see, things like saturation. These are very basic. Definitely need another pass on these to make these a lot nicer. I'd like to do some actual filmic color grading eventually, so probably get away from, I'll probably still have this, but at least have more control over it. Gamma. This is part of the equation, if you're not familiar with tone mapping, to take your previously HDR image, so high dynamic values in the render targets, take those, and then you bring this into a low dynamic range so that it can be outputted on the your monitors accurately, because those are low dynamic in resolution. Or in range, not resolution. Anyway, and then the exposure. Right now this is a default constant value, which I explicitly say what it's going to be, but eventually I'll move to auto exposure, which is, if you've ever used Unreal, you've probably noticed it whenever you load up any default scene in the editor and you look at something really bright, all of the area outside of the bright area starts to dim a bit. It tries to act a lot like the lens of a camera, the auto exposure features of a camera anyway. And then if you look at a really dark area, then the scene tends to brighten up a bit. And that's just to, again, auto adjust for the different levels of intensity of exposure that the scene has. Okay. FXAA, that one's really self-explanatory. It's just simple anti-aliasing. It's the simplest one you can do for a deferred renderer. Eventually I'd like to move to a temporal anti-aliasing. That's definitely in the works. SSAO, I have the SSAO buffer here. So this is what the SSAO pass looks like. It's very noisy. I upload this noise texture and use this in screen space to affect the samples that I'm doing for the SSAO. and you can kind of see that there. If I move around, you can see all the pixels in screen space move with the camera, but it's not noticeable at all whenever, or at least very noticeable, very I don't know what I'm saying. It's not very noticeable whenever you have the final image. Anyway, go back to this. It's a lot lower resolution than I'd probably like, and that's just because I have it, I think, at 1/4 of the screen, and then I do a blur, which is also 1/4 of the screen, and then I just composite it. The blur right now is also just one separable blur. I'd like to do a number of iterations on that. So probably have the blur at a lower resolution, and then the SSAO at a higher resolution, so that the samples are a little higher. I'm not sure. I'm going to play around with it and see all the different effects I get. But coming up here, you can have different controls for this. So I can adjust the radius, also the bias for the amount, and then the intensity, of course. And then the final blur. Yeah, so you can see the different SSAO effect here. But again, the more intense this is, and because it's so low resolution, you start to see the pixel artifacts a lot more heavily than you would otherwise. So I'm trying to find a happy in between, and I'm looking at different examples. I know there are different algorithms and equations that take distance from the camera into effect as well. So you do a depth difference. We use that at work. I'm not using it here. That's something I definitely need to go through and implement. If I do that, then that will also help with performance. That way I'm not sampling too far. Because part of the issue with this algorithm is that based on the radius, it takes a large number of texture samples, and you start hitting cache misses whenever the radius is way too high. So that's part of the issue with having the render target being full screen, is that you're sampling a lot of pixels from a lot of different areas in cache. So anyway, I'm just rambling. If I look over here, well, I guess I can show this. These are the frame buffers. Again, I showed the albedo. This is just the base color of everything in the scene. Normal buffer, so all the normal information. Actually look at the floor here, you can see all the different indentations of the planks. Position, I'm still rendering position out to part of my G buffer, which is stupid, it just wastes space. Because what you can do is you can reconstruct position pretty accurately if you have a depth buffer with enough resolution, which I do. I'm using 32 bits, which is more than plenty. I could probably use 24 and get away with it, actually. But you can reconstruct the position, the world space positions, which I use those for lighting calculations in my lighting paths. So I can get rid of this completely and save, I think, 32 bits. This is a 32-bit buffer. Yeah, so I'll do that. Emissive buffer, so this is the emissive channel. It's also in the G buffer. Anything with an emissive texture goes in there, or any kind of emissive properties. Materials, I showed this, and all the blooms, the bright. This is the final light. Before, this is the HDR rendering of the lighting. This has everything in it. It has SSAO. The only thing it's missing is all the tone mapping, essentially. So you can see another point light that I have here. And then if I turn back on the directional light, you'll see that comes back in as well. And then I can move the direction of the directional light in the scene. Turn it down a bit because it gets a bit obnoxious. And then SSAO, the noise, and then the final composite. So close this back up. Again, IMGUI is great. Just being able to visualize all these render targets makes it really easy to debug things when you're trying to deal with shaders, especially. It can be a pain in the ass to get things debugged easily. So before I show that off, I'll show this. These are just instancing that I'm doing. Just got GPU instancing working. So it's about 500,000 quads that are rendered really easily. Just taking no performance hit. With OBS off, I can get probably 1.5 million before I start seeing any kind of performance hit. But OBS is pretty big performance hog, especially the quality that I'm recording right now. I've got a bit rate of about 25 or 30,000, which is kind of ridiculous. But yeah, so Instinct's great. I'll use this instead of or maybe just in conjunction with the batch quad system that I had set up previously. I'm not sure. So this here is something I've been working on, which is a material editing system. One of the things I want is something very similar to the way Unreal does it, which is you can edit materials on the fly and save out assets, or save out materials, save out shader graphs, be able to create materials, etc. And this is the system that I've set up for here. If we look over here, so I'm not going to show everything about this because there's a lot to it, but the basic gist of this is that the engine takes in this JSON file, which is a shader graph, which if you've ever used Unreal, the shader graph is just a bunch of nodes, inputs and outputs, which define how the material is going to be represented in all the different passes that the engine uses. So I set up a node network here, I implement the node links, and then this is the main node, which has all the different inputs to it that I discussed a second ago: base color, normal, metallic, roughness, emissive, AO, and world position offset. And then I'll add a lot more later once I start getting more features into the engine. But it takes this, ingests it in the engine, it runs through this and compiles it down, and it spits out shader code. So what you're looking at here is, this is my blank base shader graph, and when this compiles down, it spits out this code for the vertex. This is the vertex shader code, and then this is the fragment shader code with all the different render targets, or the channels that go out for both the render targets and the G buffer. Cool thing about this is that I can recompile this, change it on the fly. So I will make a uniform called color, let's call it albedo, since that's what the base color is typically called. Okay, so the way this works is I have written in native a bunch of what are called templates, which define the way that these nodes are going to behave. So what happens is that the engine takes these, it ingests them, it looks for the template that this node is supposed to be using. In this case, it's a constant vec3. Takes that. There's one thing I forgot for this to work nicely. It takes that, and defining that template is just a bunch of different things, namely its inputs and its outputs. It defines how the node should be declared in code, which I'll show you that it'd be a lot easier to see once the shader actually gets output. And it also defines how it should be defined in code as well. So we look at this. This looks fine. So here, base color, we have the inputs into the main node. It's going to take the albedo, and it's going to take it with the output of the value channel from the albedo, which is the output that constant vec3s have. So if I recompile this, you'll notice that a uniform will pop up in here, and this is the albedo that I had. And now I can easily edit this on the fly. So I can change these shaders on the fly, very similar to how Unreal does it. You can recompile and then test out different effects. And again, if we look back at the shader code, you see now we have a uniform vec3 albedo. This is what was defined here in this node. And you'll see that the albedo out is using the vec3 as part of the color. And that's what we get here. I can also use things like texture maps. Oops. Live coding always works well. Oh boy. Come on, Sublime. There we go. So yeah, let's do a texture map here. It has a template of a texture sample. Yeah, I type for a living, believe it or not. Texture 2D sampler node. And its output that I want is the RGB channel of that. And again, I'm not just making these up on the fly. These are defined, again, in native as a template that the engine looks at in order to know what this is. If I give this, actually I'll show you that. If I give this an output that just doesn't exist and try to recompile it, you'll get this, which is pretty clear indication that I've messed something up. And if I look at the shader code, then I output an error for myself, which is to say that I have an incorrect link at the normal channel in my main node has an incorrect link with the normal map. So I go and look at that and I see that, okay, yeah, I'm using the incorrect link. So I need the RGB channel, which is what's actually defined in the template, recompile that. So there we go. So now I've sampled the normal map. I am bringing that from tangent space. And then doing the tangent TBM matrix operation on the normal, and then setting that to normals. Anyway, so now what I have is a uniform with all my normals, or my normal map, and this is what I'm listing here is all the textures that are currently in my asset manager database right now. So if I actually find a normal map, there you go. So now I'm actually using normals on there. Okay. So again, very easy to just change things out and just kind of play around with things. And then just for the hell of it, we'll do metallicness, which this will be just a float. Also, the way that this actually pops up as being uniforms in the UI representation of all of this is that I have, no, that's not what I need. I have to explicitly tell it in this node graph that it is going to be treated as if it's a uniform. And then it'll pop up. If I don't do that, I'll actually show that. Metallic value. And here we'll use the roughness. This is metallicness. Again, ideally, I won't be typing these. I'm going to define or create a UI eventually. It's some kind of little editor so that I can not have to do this by hand. But, okay, so I won't declare this as uniform. What it's going to do then is it's going to look for the default value of this roughness, or the constant float node, which I think defaults to 0. I'll recompile this, and you'll see that the roughness doesn't show up as uniform, so I can't actually manipulate that, but the metallicness does because I declared it that it's going to be a uniform. So I can manipulate the metallicness now of this object, so now it kind of looks like a metallic eye, which is weird. But again, if I come back to the shader graph and then declare this as a uniform, and then recompile, and then now I get my roughness uniform. Yeah, so that's about it for this. Just wanted to quickly show that off and the progress I've done on that. Hopefully the next time I do a video I'll have maybe a small node editor up that'll actually show this, and what it'll do is it'll spit all this out for me, so I won't have to write this by hand. It'll be a lot less error prone than having to do this. Yeah. Oh, just took a big frame hit for some reason. Probably because of OBS again. There we go. That was strange. And then the very last thing, just to show off real quickly, there's some other stuff in here. There's a lot of lower engine stuff that it's just hard to show on video, namely all of the cleanup that I've done and refactoring, mainly with Entity Manager system, and then also all of my asset systems. Actually, something to show off with the asset system is that you see that there's this checkered texture on all of these shader balls here. That's a default texture that I've created. So if at any point I reference an asset that doesn't exist, what I've done is for any of the assets that the engine can possibly ingest, or all the resources that it can possibly ingest, I create a default asset that associates with that. So if I try to load a texture, or some asset references another asset that does not exist in the database, then I'll load up the default. So here, these are trying to access some texture that doesn't exist, and so they've all been given this default texture. Unreal does something very similar. You can see they have, I think it's a checkered texture as well. Theirs is gray and white though, but you can see it whenever an asset's missing. What we use at work is just a really bright pink. It's the magenta mask color that sprites used to use. It's pretty obnoxious, so you can very easily tell that you're missing a texture. But I like the texture, the checkered texture. I think it's cool. Anyway, last thing I want to show off. Let me turn the bloom down a bit. About like 0.5. Yeah, that's fine. Physics. So I've integrated Bullet into the engine. Right now it's just kind of floating out in the game class right now. There's no systems to it at all. That's not been abstracted, so I need to go through and clean that up. But Bullet was really easy to get integrated. Yeah, so I'll hopefully get some time to mess with this and write a proper physics layer. Right now all I can do is just shoot these different material spheres and have them interact with one another. Yeah, so you can just see all the bloom working pretty well with that. Anyway, I think that's about it. So thanks for watching.